Now let's look at admittance. First, we define admittance that we use capital Y as the reciprocal of impedance. And that, by definition, also is the current divided by voltage. And of course, in phasor expression, it has magnitude and phase angle. The unit is Siemens. Now, in the rectangular coordinate, we express that in real part and imaginary part, we break into G, which is conductance, and the imaginary part B, which we call susceptance. So this B is called and the G is conductance. Now remember that impedance, so we can relate to the impedance, resistance, and reactance. And the relationship here that we can have is a G, which is the conductance, is R divided by R squared plus the reactance squared. And the susceptance, B, is equal to the negative of reactance divided by R squared plus X squared. Now, what happens for the admittance in circuits? For resistor, that admittance is simply just the reciprocal of the impedance, which is just R. So this one is just equal to 1 over R. And for inductor, the YL is equal to the reciprocal of the ZL, which is 1 over J omega L. And that is equal to the negative of 1 over omega L. And the phase angle is 90 degrees here. But remember negative sign. We can absorb the negative sign inside to make it negative 90 degrees. Now, similarly, for capacitor, that YC is equal to 1 over J omega C, which is simply just J omega C. And then we can write as omega C 90 degrees here. And remember, if we wanted to carry the unit, that is the unit. Now for combination, in parallel, if we remember, for impedance is the reciprocal of the total, and that makes the reciprocal of the total Y is equal to 1 over Z, which makes Z1, plus 1 over Z2, that makes Z2, Y2. Now if we have more than that, and we just keep adding it, you can see that is convenient for parallel circuits, that we use admittance more often than impedance. Now for series connection, we probably see it already, that z, which is 1 over y, is equal to z1 plus z2, and that will be 1 over z1 y1 plus 1 over y2, and if we have more, we just keep adding the same thing here. So it's really similar, very similar to the operation of this admittance is very similar to the impedance. It just depends on the convenience, whether we wanted to use the reciprocal or adding the reciprocal, or we just want adding the quantity itself. So we can sometimes use admittance instead of impedance. Now, if we wanted to look at an example, see how these two are really related in a real example.